Honda's adaptive cruise control system is a sophisticated safety technology that requires precise calibration to function properly. Understanding when and why calibration is needed is essential for maintaining optimal performance. Honda's ACC system relies on three main components working in harmony. The millimeter wave radar unit detects vehicles ahead, while a monocular camera provides visual recognition. The electronic control unit processes all this data to control your vehicle's speed and following distance. Calibration becomes necessary in several common situations. Battery disconnection requires a complete system reset. Windshield replacement affects camera alignment. Front-end collision repairs may alter radar positioning. Software updates can reset learned parameters, and any sensor maintenance triggers calibration requirements. There are four main types of calibration procedures. Basic reset clears stored data and error codes. Static calibration uses alignment targets with the vehicle stationary. Dynamic calibration requires highway driving for 15 to 25 miles. Complete recalibration performs a full system relearn of all sensors and parameters. Modern Honda ACC systems from 2024 and 2025 feature enhanced integration with lane keeping assist and collision mitigation systems. Newer models from 2023 onwards receive over-the-air software updates that can affect calibration requirements. Most 2022 and newer models require both static and dynamic calibration procedures using Honda-specific diagnostic tools version 3.016 or newer. Proper calibration is critical for safety system functionality. Understanding these fundamentals ensures your Honda ACC system operates at peak performance, providing reliable adaptive cruise control and enhanced driving safety. Honda ACC calibration follows a precise four-phase process. Each phase must be completed in sequence to ensure proper system functionality. Phase 1 is pre-calibration preparation. This critical step ensures your vehicle and environment meet the requirements for successful calibration. Start by inspecting tire pressures to match manufacturer specifications. Verify proper wheel alignment and check for any physical damage to radar or camera sensors. Most importantly, verify battery voltage is above 12.4 volts. Low voltage can cause calibration failures and system errors. Environmental conditions are equally critical. Temperature must be between 32 and 104 degrees Fahrenheit. Ensure dry conditions and use a level surface for static calibration. With pre-calibration complete, we move to static calibration using the Honda Diagnostic System. Static calibration requires the Honda Diagnostic System, or HDS. Connect the diagnostic tool to the vehicle's OBD port using the communications cable. Through the HDS interface, clear all stored diagnostic trouble codes, then perform the Initialize ACC System function. Verify sensor communication status before proceeding. Static calibration establishes baseline sensor parameters. Next comes dynamic calibration through real-world driving scenarios. Dynamic calibration requires highway driving at 45 to 65 miles per hour, for a minimum of 15 miles. The system must experience multiple following scenarios with various vehicles, include lane changes, curve navigation, and stop-and-go traffic scenarios. This teaches the system to recognize real-world driving patterns and target vehicles. After completing the road test, return to verify system status and document successful calibration completion. Final verification ensures all systems function correctly. Check system status through HDS, test all ACC modes, and verify proper target acquisition at various distances. Document the calibration completion for warranty compliance and quality assurance. Proper documentation protects both technician and customer in case of future system issues.